All right, we're going to do a really in-depth deep dive on just displacement versus time graphs. In my previous video, I talked about all different types of motion graphs and kind of a brief overview of everything. So if you haven't watched that, I suggest you go and watch that first. But let's go and take a really close look at just displacement versus time graphs. All right, we're going to start off by interpreting this displacement versus time graph that's sitting in front of you. Now, what I suggest you typically do with these is you break them up into sections whenever something is changing. So if you noticed on this first section over here on the left, we're going to call this section 1, you got a increase in your displacement over time. And then we got this flat line section. I'm going to just kind of divide this up. So we'll call this section 2 right here. And then we have this downward direction going on over here. So we're going to just create another section out of that. We'll call it section 3. And then finally we got this upward line at the end. We'll call that section 4. So we're going to break this up and talk about each individual section. Now, what we have here in the first part in section 1 is it shows that we have a velocity. Okay, so we're actually moving here. And this velocity is going to be positive because we're moving in the positive direction. That looks like an X. Let me see here. It is a positive velocity. All right, so we're moving forward at a constant rate, and that's what's happening in that first 3 seconds on this. And then the second part, you're staying still, so there's no velocity, so 0 meters per second. This third part right here, you notice it's a long downward slope, and it goes past the x-axis. So just because it goes past the x-axis doesn't necessarily mean the velocity changed in any way, because the slope is staying the same. There's no change in that slope. And we talked about slope in the last video. So what's happening here is you have a velocity, so velocity, but it is negative because it's going downwards. So that shows a negative velocity. And then this last section here, you got your slope going upwards, so that's a velocity, and it is positive. So let's use this little car I have down here. We're going to use this to represent what is happening in this graph. So we're going to say where the car is sitting right now, we're going to say that's 0. We're going to say over here this is positive 3, and back here we're going to say this is negative 3. Okay, so I want to try to get everything in this graph. So that first section, the car starts at 0. You notice that on the graph, it starts at 0. And then it moves forward to 3 meters, and it does that in a period of 3 seconds. So that would be like 1 1,000, 2 1,000, 3 1,000. So it took 3 seconds to get to that 3 meter mark. And then in that second section, it's set still. So instead of going anywhere, it's set here for a couple seconds. It's set there for 3 seconds. If you look at the graph, it's set there for 3 seconds. And then over the next 2 seconds in that section 3 from time 6 to time 8, you notice that the car went backwards. And how far backwards did it go? Well, it went all the way back to negative 3. So it went all the way back here. And then the last section, it went forward back to the 0 part. So for section 1, it went up to 3. Section 2, it set there. Section 3, it went to negative 3. And then section 4, it went back to 0. Okay, so that's kind of conceptually what was going on in all of those different sections. But I want to go a little deeper than just that. I want us to talk about what the velocity is in those sections. So let's get this car kind of out of the way over here. And we are going to mathematically figure out what the velocity is in section 1, 2, 3, and 4. So for section 1, we remember that the slope of the line on a displacement versus time graph gives us the velocity. So for section 1, the slope is equal to rise over run. So remember, rise over run. And then our rise for section 1, it goes up here to negative 3. So that's negative 3. And it does that in a time period of 3 seconds. So that's 3. Oh, I'm sorry. This isn't negative 3. That's positive 3. Forgive me. So 3 divided by 3 is 1, so the velocity is 1 meter per second for section 1. Section 2 is really easy. We already said that it's 0 meters per second because it's a flat line. There's no slope there. So let's just skip ahead to section 3. Section 3, we have our slope is rise over run. So how much is the rise? Rise over run. So how much is the rise? Well, it starts off at positive 3 and it ends at negative 3. So the rise is, remember, y2 minus y1 divided by x2 minus x1. That's for the run. So y2 is where it ended at, which is over here. So negative 3 minus the y1, which is positive 3. Okay, so we got negative 3 minus 3. Then x2 was 8 seconds minus x1, which was 6 seconds. So that gives us negative 6 divided by 2, which gives us negative 3 meters per second. So that'll be the velocity in section 3. And then let's scroll down here. We're going to look at section 4 from here to here. So for section 4, rise over run as always. And that's our y2 minus y1 over x2 minus x1. So what we have here, our y2 is where it ended, which is 0. It ended at 0. And then our y1 was negative 3. Okay, so minus negative 3. And then divide that by x2, which our time was 11 at that point, minus x1, which was 8. So we got 0 minus negative 3, which turns to positive 3. And then 11 minus 8, well, 11 minus 8 is 3, so that gives us 1 meter per second there. All right, so that's just a quick and dirty version of how to calculate the slope on these, and you can see how you can use that slope formula to figure out the velocity of the car as it's moving. Now let's go down and look at this one over here. We're not going to mathematically go into this one. We're just going to talk conceptually about it and figure out what exactly is going on in this graph. You notice it's curving the whole time. There's no straight line in this. It's just a constant curve. So what you want to remember is the concept of the steeper the slope, the faster it's moving. All right, so keep that in mind. The steeper the slope, the faster it's moving. If you look at the first little section of the graph right here, that's a pretty steep section of the slope, right? Now, if you move up, it gets a little less steep, and then you get up to the top, and it's flat, generally speaking, and then it starts to get steep but going downwards, and then it gets steeper going downwards again. So what is actually happening here? Well, the first part here, we have our velocity, and it's positive, and it's a pretty fast velocity. So we got a positive velocity, and we're going to say it's fast. So it's going really fast at that point. And then we got the second section here. It's still a positive velocity, but it's going slower. Okay, so it's going slower than it was originally. So what that means is it's slowing down. And we can call that deceleration. Whenever something is going really fast and then it goes to a slower speed, we call that deceleration. So this top part right here is at rest, so there's no velocity at that point. So v equals 0. And then we're going to go to this point right here. At this point, the slope is going downwards, so that's a negative velocity. And it's going kind of slow because it's not a very steep slope, or it's going slower, I should say. And then finally over here on this last part, we have a negative velocity again, but it's going kind of fast, or faster than what it was before. So let's look at our car again here, and we're going to kind of visually see what's going on. So it starts off going really, really fast. Okay, so it's going really fast, but it slows down, and then it comes to a stop, and then it starts to speed up in the backwards direction, okay? So we can kind of actually break this up into sort of two sections. Let's divide this in half, okay? That was a terrible line. Let's fix that. Let's divide this in half. Come on. There we go. And the first section, what's happening is you're slowing down. So you're going slower and slower as you're going through this first half of the curve. So it's like you start off really fast and then you slowed down and then you came to a stop right in the middle. And then the second half, you're actually speeding up. So you're speeding up. Your slope is getting steeper and steeper. Now you're just speeding up in the backwards direction. So the first half, grab it, there we go. The first half you were going fast and then you came to a stop and then you sped up backwards. That's what's going on. You start off fast, stop, and then you sped up backwards. Let's look at another one. It's the same type of graph except it's flipped over. So what's happening here? Well, let's grab the right color. So you start off with a steep line, not as steep, flat, and then not so steep, and then steeper. Okay? So the first section right here, all right, so you are going in the negative direction. That's a negative velocity, but it's a steep line, so you're going fast. This is once again a negative velocity here, but you're going slower. Here you're at rest, so you're not moving. And then here you got your positive velocity again, but you're going slow in this case. And then you got your positive velocity again, but you're going faster. All right, so that's whenever you're like really picking up the speed. So what could we say here as the car, with our example? Well, it started off going fast, but in the backwards direction. So it would be like starting off over here and then going fast, but slowing down, coming to a stop, and then taking off forward. Okay, so really fast, slowing down, stop, take off forward. That's what's happening here. So if it's negative, remember it's just going backwards, positive is going forwards. And if it's flat, you're at rest. And remember, the steepness of the slope or the steepness of the curve shows how fast you are going. All right, so let's look at another one here. Here's a little more complicated one. And you notice this one is all underneath the x-axis, underneath that time axis. So what's happening here? Well, let's just continue the same process and break it down. Right here, you got a pretty steep slope, relatively. So here, you got a positive velocity because it's going upwards. And this would be kind of the fast section of the graph. And then as you get up further here, you still have a positive velocity, but you're going slower, right? And then here's where your rest is. You got your rest at that point. And then you got your section over here. That's a negative velocity. And we'll say that's kind of like a medium speed. I don't know if that's really faster or slower, but it's kind of in between. So you notice since this is all underneath the axis, all that means is that we called this the 0 point, and let's say this is -6 over here. So what was happening was it started off at -6, and it was taken off, but then it slowed down. It came to a rest right before it hit 0, and then it started picking up speed again, going backwards. That's all that was happening there. It just started off right here, and then it didn't quite get to 0, but then it went backwards. So just conceptually what's going on, that's what's happening here. And the whole time you notice it's accelerating. Anytime there's a curve on these, remember, that shows acceleration. So let's look at this one now. We got a curve, and it's all underneath the axis. So you got your steep area, it gets less steep, rest, positive velocity, gets a little steeper, and it's positive velocity again. So it's kind of the same concept of what just happened before. It's like here's 0, and then it looks like it gets not quite to -7, but we'll use that as the example. So it starts off at 0, and it's going fast backwards, but it slows down, and before it hits -7, it comes to a stop, and then it speeds up going forwards again. So that's what's happening in this graph, conceptually. Now let's look at this last graph that we have here. What's happening? Well, we kind of want to break it up into a couple different sections again. So let's break it up there, and then let's break this up, and then we'll have 3 sections, all right? So we'll call this section 1, section 2, section 3. So what's happening in section 1? Well, it's a flat line, so you're at rest. You're not moving there. And what's happening at section 2? Well, here you're actually accelerating. You're speeding up because you notice there's a curve there. And then section 3, this looks like a constant velocity. What's going on here? So constant velocity. You notice the line gets straight at that point. It doesn't keep curving in section 3. It stays straight. So this is a really good example of what a motion graph would look like of a car sitting at a red light. So it's just going to be sitting there waiting for the light to turn green, and then it's going to accelerate and then hit a constant velocity afterwards. So this is kind of just how people drive, right? You're sitting there, you're resting, then you speed up to the speed that you want to go, and you just kind of hang out at that speed afterwards, okay? So as far as displacement versus time graphs, that's a really quick and dirty vision on what all of it is, all the different types of scenarios that could happen. Anyway, thanks for watching. I have more videos on other physics topics and more videos on this one, so I suggest you go and watch them. If this was helpful to you, hit that like button. It really helps me out. If you want to see more videos, hit that subscribe button. And if you want to add anything to this video, go ahead and put it in the comments, and I'd appreciate it a lot. Thanks.